So the next thing is to get Florence moving to the right and to the left. I've got the pulley for the rotating spring made and sprayed, and because I'm not planning anything, I didn't think about putting a gear on to work some other little mechanisms. So I've cut that out on the laser cutter, carefully positioned it in the middle using that as a sort of lining up jig, the cut out bit, and then marked and drilled holes so I can screw this on. I'm going to make that chrome, I'm going to spray that chrome, and then that will be able to rotate. It'll look nice through there, and that'll rotate and move some other gears and things as it turns. Also made the support for this. We've got the hole down here where the stepper motor will go, so that's going to be sitting something like that, and I've cut, because it's going to be sitting with this vertical like that, I need it to have a lot of strength at the joints, so that's why I've cut it like a sort of finger joint. So that basically increases the number of surfaces that the glue is going to adhere to. So it's going to keep it very strong. And to make it even stronger, got out a little bracket, and that really beautifully just pushes in there. So I'll glue that in as well, and then that's what's going to support the servo motor, not stepper motor, servo motor, and we'll turn this. And this assembly is going to fix in this side up here, so that this spring will go around the pulley and then join onto that pulley, which is going to be able to rotate. This is so interesting and exciting. I've got the paint, well, the paint's now dry, so I've got the original large pulley, I've got the silver painted gear ring, got the beautiful support for the servo motor, and I'm going to fix this gear ring onto the original pulley with some little copper rivets that I've got. I could screw it through, but I reckon I'm just going to fix that on and glue each of the rivets in with super glue, and that'll absolutely be fine. That's not too bad, it's not too shabby. So that's all mounted on that bracket. Now I'm trying to sort out some gears and things that the silver ring teeth, what am I trying to say, teeth ring? No, gear ring can drive. Standard drill bits come in 0.5mm increments. I wanted a 4.1mm, and you can buy all different sizes really precisely. Quite often, because if you want to tap a hole, a tap drill has to be an odd size, not a standard 0.5mm increment. So here's my lovely precious 4.1mm drill. Let's put it in the chuck and drill the holes. I've seen worse, we'll have to give it a go. Let's do this one. With a bit of luck, that's properly centred. My battery on the camera's going flat, so see you in a while after it's recharged. Apologies for the quality and sound, but I forgot to charge up the other camera batteries again. I tried drilling a hole here to put in the gear that was going to, this one, that was going to transfer the movement, the motion from this silver ring gear. And obviously it all snatched up and the hole went all lopsided and everything wrong. You know when you don't have enough sleep, when you just sleep really badly and everything you try and do the next day just goes wrong. Some days everything works, other days when you haven't had enough sleep it just doesn't. So annoying. So I've drilled this one out slightly larger to allow for a bit of movement, found a scrap of plastic and drilled the two holes so that these two gears turn freely. The idea being I can mount this on the back and have two larger holes through which the two things will go, the two drive shafts. It really doesn't make much sense. At the moment what I'm doing is I've drilled the two holes in this for the two gears, and I've drilled smaller holes into them ready to tap them, because I'd like to be able, well, to assemble them and also to repair them. I need to get them in and out, the little shafts. Having almost ruined this the first time, drilling a hole just holding it by hand as it flipped through and grabbed it and spun it round, I almost did the same again, but then I thought, no, be a grown-up. Think what grown-ups would do. I mean, a grown-up would clamp it down with a G-clamp so it's nice and firm and can't leap off and slice up fingers and things. And that's what I did, and it worked perfectly. Yeah, live and learn. So we've got this fixed on now, so it makes a bit more sense. There are the two screws that are holding in the drive shafts and a central screw to hold that in place so it can be adjusted. And these now spin perfectly, and what it means is I can adjust that, move those two gears around until they just bear properly as that one, like so. Right, the big camera battery is charged up, and what I've done during the meanwhilest is I've put that together and fixed that up underneath the Florence's enclosure. If I hadn't mentioned it before, it's such a useful thing. It's well worth spending a little bit extra in getting a good quality one, because there are some rubbish ones around with rotten bearings in. But just to actually be able to drill holes or put screws in where you can't reach, where there's not enough room for a whole handheld or some other screwdriver or drill system, this is perfect. Isn't there some saying about madness being like doing exactly the same thing over and over again and expecting a different outcome? Because I've done exactly the same thing over and over again. I've used this spring, a pulley chain, well, pulley spring, to link Florence's body to the head turning pulley, and surprise surprise, you have to take up an awful lot of tension. I've just got the servo going through from 0 to 90 to 180 and back 90 to 0. So she should be turning her head right the way round, because I did the calculations with circumferences and things, and theoretically that pulley is bigger than that pulley. So 180 degrees should turn her body right round, what, about 270 degrees worth. But it isn't, and you can see that the pulley turns and then enough to take up the slack in the spring. And then she suddenly lurches round. And I've had exactly the same problem with the climatic revelator, and I had to in the end use the ball chain. So I've done exactly the same thing again, I don't know why, and exactly the same thing's happening. And the fact is, a jerky sort of movement doesn't matter too much, but she doesn't turn far enough to be able to see the gauges, the Is It Time for Tea gauges either side. It's just too unpredictable. I've made an executive decision, because I've got so much of this brass ball chain already on the machine, all these bits and pieces that are constantly moving, I think it's going to be too much. So what I'm going to do, I'm going to use this really fine welded chain. Just before I went to the trouble of replacing the spring with chain, I thought I'd just try an experiment with some string. So I've just got two little bits of braided cord, and as you can see it's dropped off already. It needs some tension. I had tried it with a couple of little springs sort of in line, but it was so jerky again. I'm wondering whether I should use a proper stepper motor where I can accurately control the speed, because this is quite heavy and yanking it about is going to put a lot of force and strain on different components, and I don't know how long this servo motor is going to last. A stepper motor has this type has four electromagnets inside, and they're controlled, switched on and off in a special sequence by something like an Arduino. These little ones are brilliant. They're fairly cheap. I think it's like £3.80 I think you can get them for. They work off 5 volts, which is great because that's what the Arduino works off. And they come with a little interface, which is basically a series of electronic switches that something like an Arduino can switch on and off, and these switches switch the higher amount of electricity, the higher current that the electromagnets inside require. Inside these ones there are lots and lots of gears, and I think, if memory serves, that you need 6,500, something like that, 6,500 steps of these circular steps with these little electromagnets to get this output shaft to rotate once, which means it's extremely powerful. The only downside is that the Arduino that's controlling this, or whatever else you're using, doesn't know where whatever it is this is joined to is. If something's just turning round and round and it doesn't matter, that's fine, you don't need it. But in the case of this, with Florence's body, if I'm going to use one of these stepper motors, I need some sort of sensor to tell me, so that when I first switch her on, and this is all now completely tangled up with all the string, when I first switch her on, she needs to find, by turning the stepper motor sort of to right to left with some sort of little sensor, I usually use a little reed switch which works off a magnet that's hidden somewhere. So she turns backwards and forwards until the reed switch switches on, and then the Arduino knows where she is and then can remember that and very accurately control how she moves, always remembering where 0 is, if you like. Right, so I've finished this little connector. You can see that this little stepper motor's got two flats either side, and it fits on really nice and snugly, and then I can use this little Allen key to tighten them. I'll tighten them both sides in the end. That's now clamped on. I've got this bearing that I'm going to use because it's going to be quite a long distance between this pulley and the motor. So we're all ready for assembly. We've got the support, which is still the same as it was for the servo motor. We've got the new stepper motor. We've got the main pulley with an extra little bit stuck on the back, into which the new turned brass motor linkage will fit. We've got a lovely bearing. We've got a new front part which is going to support the bearing. A little insert that's going to fit into there, and a 10mm thick spacer and motor support onto which this will fit. How exciting! I've connected the stepper motor interface up to the Arduino and written a bit of software and downloaded a stepper library. So here's the little interface, and you can see it comes with 4 little LEDs to show you it's working. You can see immediately why stepper motors take a little bit more trouble, because in addition to having to have a switch to tell them where they are, you've got a huge bundle of, well, you've got 4, 5, 6 at least wires that need to connect to other bits and pieces, and 4 wires that need to go to the Arduino. This little interface does the switching, and the wires then go to the stepper motor, which is working perfectly. It's lovely and quiet. I've set it to 6 revolutions per minute. If you're watching, well done, congratulations on your patience. I thought this part of the project, getting her engine to turn leftward and right, was going to be really easy, but it's turned into a bit of a nightmare. After I got the stepper motor sorted out, which you can see working there, I ended up putting the reed switch in a little piece of copper pipe that's supported, and having the magnet, there's the magnet underneath a nice little bit that stuck out from the base. It all worked, and I set the stepper motor to go around to the right until the switch switched on, the reed switch, and then to stop it and to know where it was. And then the day after I started it all up again, and for some reason it didn't work. I don't know why, I don't know what changed, but I just felt a little bit wary about that as it stopped working after one day. So what I went ahead and did, I'll take the back off. Oops, a daisy. I used a little micro switch, so when you first switch it on, the motor turns round and it just bumps into that little micro switch and lets the Arduino know that where it is, that's its limit. You can also see there's a sign of very, very poor, if absolute absent design considerations, because as her body turns, as the engine turns round, it actually pokes out the back of the cabinet. Not by very much, I have to say, so I took the opportunity to do a nice little rebate, a little feature, and on the back a nice little stained panel which actually goes really nicely with the rest of it. Other issues, moving along swiftly. The stepper motor started stalling. It just wasn't powerful enough to turn the engine, so I got rid of the original pulley that was large and made it much smaller, which didn't matter now because it can turn as far as it wanted, and as you can see the chain now wraps round and round a couple of times, so that's not a limit anymore, and it in effect has more power. I also found that this nice little pulley thing that changed the direction of the chain, having fiddled around with the chain and springs for ages, I couldn't work out how to do it, and in the end, moving swiftly around the back, came up with a rather pleasant, even though I say so myself, little tensioner. It's got a spring that keeps this bottom pulley pulled really taut, and that just takes up any slack in the chain, and that really works very nicely and adds another bit of complexity to it all. I'm really pleased it's all working properly. I thought I'd leave this copper pipe in anyway because it looks nice and interesting. So thank goodness, finally that part of the project is finished, so I can move on now. Thanks again for watching. Please do subscribe to my YouTube channel, and if you'd like to buy any of the inventions and things, my steamhead.co.uk webpage is a good place to start. Thank you very much.